So this question, we have a fireman holding a hose pipe. So the water leaves the pipe horizontally. And this is easiest to understand if we draw a detailed picture. So we have our hose like this. And the water leaves the pipe horizontally. The pipe has a constant cross-sectional area, so it doesn't expand. The magnitude of the force exerts on the hose pipe is F. So the force of the hose on the fireman is in that direction, and the force of the fireman on the hose is in that direction, and we are calling that F. Well, what we know the definition of the force is, it's the rate of change of momentum, delta P over delta T. And delta P is m delta V over delta T, or delta M delta V over delta T. And so we know that is equal to F. And if we examine this pipe, what we see is that there is this water, let's say, that moves and occupies this new area when it comes out. So that water that's blue moves into this yellow area. Okay? So that's what happens. We have a delta M represented by the blue, an M that moves from the blue to the yellow. And if we were to take any particle, let's say at that edge, moves to that edge. And a particle here moves to here. So we can see what's going on with the motion. Now, let's consider that pipe under the new circumstances where we are told the volume of the water per second doubles. So let's imagine happens. So the volume, for us to get twice the volume, we are now looking at that much volume. And that volume is going to move here like so. So what we have now is we have this M and this M moving to this location. So in terms of the delta M, delta V over delta T, the mass that is moved is twice the mass. But what is not obvious to see in this case is that this water molecule here has now moved to here. And this green water molecule that we might say is here has moved to here. So what that means is in the same amount of time, those molecules have moved twice as far in the same amount of time. So the velocity is twice the velocity in the same amount of time. So we end up with 4. So before we had 1m, 1v over delta t. So we have mv over delta t with all those coefficients being 1. Now we have 4mv over delta t. So that means the force is 4 times as large. And that's a non-intuitive answer for that to be the case, but it only comes by us really looking down at the definition of force, which is the rate of change of momentum, and we can see that twice the mass is moving at twice the velocity. And we need twice the velocity for that mass to come out in that same size pipe. And that's why the answer is choice C.